Hello students, I am Manoj Kundare, the Assistant Professor of Electronic Science. Welcome back to our e-learning platform. In previous video, we have seen the concept of the parity generator. The link of the previous video is available in the description box. Please check it. Now, in this video, we are going to see the concept of the parity checker. The parity checker is a combinational logic circuit that checks for the possible errors in the transmission. The circuit can be an even parity checker or an odd parity checker, depending upon the type of parity generated at the transmission end. When the circuit is used as an even parity checker, the number of input bits must be even. When the circuit is used as odd parity checker, then the number of input bits must be always odd. That means at the transmitter we use the parity generator circuit, but at the receiver we have to use the parity checker circuit. If the parity transmitter is done with the even parity, then at the receiver we requires the parity checker circuit with the even parity also. Okay. There are two types of parity checker circuit, even parity checker and second is odd parity checker. Let's see the details about even parity checker. Consider 3 input message along with even parity bit is generated at the transmitting end. These 4 bits, that means the 3 input message A, B, C and 1 is parity bit, total 4 bits. These 4 bits are applied as input to the parity checker circuit, which checks the possibility of the error on the data. Since the data is transmitted with even parity, 4 bits received, the circuit must have an even number of ones. That means if the data is transmitted with the 3 bits A, B, C and P, if the parity bit is even parity, then the transmitted data, that means this 4 bit, must have the even parity. If this data has the odd parity, then the error is introduced into it. If any error occurs, the received message contains odd number of ones. The output of the parity checker is denoted by PEC, that means parity error check. Okay. Now let's see the even parity checker truth table. The table shows the truth table for the even parity checker in which PEC, that means CP is equal to 1 if the error occurs. That means if the error occurs, then we have to place 1 in the place of CP. That is, the 4 bits received have the odd parity, odd number of ones, and if PEC equal to 0, if no error occurs, if the 4-bit message has an even number of ones. That means in short we can say that for even parity checker, if the received data has the even number of ones, then we have to place 0, and if the received data has the odd number of ones, then we have to place 1 here. Okay, let's consider the situation here. In first situation, A, B, C and P, there are 4 zeros, that means there is no number of ones, that means 0 ones. 0 is an even number, hence we have to place 0 into it. In the next case, 0, 0, 0, 1, there is one number of ones. This is the odd number and we are seeing the even parity checker, hence the error is introduced here, hence we have to place 1 here. In the next case, here the total number of ones is 1, 1 is odd number and we are going to see the even parity, hence the error is introduced here, hence we have to place 1 here. Similarly, we have to check all this combination. Consider this combination 1 0 1 0. Here there are total 2 number of ones, that means 2 is even number, hence we have to place 0 here. Consider this combination in this combination there are total 3 number of ones. 3 is a odd number. We are going to see the even parity. Hence we have to place 1 here. Now let's consider the last combination here. In this combination there are total 4 number of ones. 4 is an even number and we are seen here the even parity bit. Hence there is no need to place 1 here. We have to place 0 here. Similarly, we can write this parity check bit with all the combinations from 0 0 0 0 to 1 1 1 1. Okay, I hope you all understand how to draw the truth table for the same. Now let's find the K map for the same. The K map is A B C P. AB has the combination 0 0 0 1 1 1 and 1 0. CP has the combination 0 0 0 1 1 1 and 1 0. Now put the ones here. This one is for the combination 0 0 0 1. That means 0 0 0 1. This one, the combination is 0 0 1 0 0 0 1 0. For this one, the combination is 0 1 0 0 0 1 0 0. For this one, the combination is 0 1 1 1 0 1 1 1. For this one, the combination is 1 0 0 0. That means 1 0 0 0. For this one, the combination is 1 0 1 1 1 0 1 1. For this one, the combination is 1 1 0 1 1 1 0 1. And for this combination, for this one, the combination is 1 1 1 0 1 1 1 0. Okay, we get this K map. In this K map, there is no octet, no chord, no pairs. All the ones are in its single state. Okay. This is the K map for the parity check bit. Now try to simplify this K map. Okay. For this one, the associated product term is A bar, B bar, C bar, P. For this one, the associated product term is A bar, B bar, C, P bar. Okay. For this one, the associated product term is A bar, B, C bar, P bar. Okay. For this one, the associated product term is A bar, B, C, P. A bar, B, C, P. For this one, the associated product term is A, B, C, P. Sorry. A, B, C bar, P. For this one, the associated product term is A, B, C, P bar. For this one, the associated product term is A, B bar, C bar, P bar. Okay. For this one, the associated product term is A, B bar, C, P. Okay. Now try to find the common terms. In the first two terms, A bar, B bar is common. Hence we can write here A bar, B bar, C bar, P plus C, P bar. In next two terms, A bar, B is common. Hence we can write A bar, B, C bar, P bar plus C, P. In the next two terms, that means in these two terms, the common term is AB. Hence we can write AB in bracket C bar, P plus C, P bar. In these two terms, the common is AB bar. Hence we can write C bar, P bar plus CP. But we know that C bar P plus CP bar is C XOR with P and C bar P bar plus CP is C XOR with P. Hence we can write the equation as CP is equal to A bar B bar in bracket C XOR with P plus A bar B in bracket C XOR with P plus AB in bracket C XOR with P plus A B bar in bracket C XOR with P. Here we can see here that in these two terms C XOR P is common and in these two terms C XOR P is common. Hence we get the equation as here the C XOR P is common. Hence we get A bar B bar plus AB. In this term is common, hence we get A bar B plus AB bar. Okay. After simplifying this, we get A XOR B XOR with C XOR with P. I hope you all understand how to simplify this K map. Now let's draw the logic diagram for this equation. The logic diagram is very simple. That means A XOR with B and C XOR with T. Okay, and one more XOR gate is required to complete this diagram. Okay, this is the logic diagram for this equation. I hope you all understand this. Now let's see the odd parity checker circuit. Consider that 3 input message along with odd parity bit is generated at the transmitting end. These 4 bits are applied as input to the parity checker circuit, which checks the possibility of error on the data. Since the data is transmitted with odd parity, 4 bits received at the circuit must have an odd number of ones. That means in odd parity checker circuit, the received data should contain odd parity of ones. Okay, if it contains even parity of ones, then the error may introduced in this data. Okay, if any error occurs, the received message consists even number of ones. The output of the parity checker is denoted by PEC, that means parity error check. This is the truth table for the odd parity checker circuit is shown, in which these 4 bits are received at the receiver, and we seen that if this data contains even number of ones, then there is an error and it is represented by 1. If this message contains odd number of ones, then there is no error and it is represented by 0. Let's see the combination for ABCP. For the first combination ABCP 0 0 0 0, there is no ones, that means 0 ones. 0 is even number, hence the error is introduced because we are going to see the odd parity bit, hence place 1 here. Okay, in the next combination the received bits are 0 0 0 1. Here the total number of ones is 1. 1 is odd number, hence place 0 here. Similarly, for this combination, the total number of ones is 2. 2 is even number, but we are going to see odd parity, hence we have to place 1 here. Okay, I hope you all understand this combination. Now let's see this combination. In this combination, the total number of 1 is 3. 3 is odd number and we are going to see the odd parity, hence place 0 here. In the last combination, that means in this combination 1 1 1 1, there are total 4 number of ones. 4 is even number, we are going to see the odd parity, hence place 1 here. That means error is introduced here. I hope you all understand how to write the truth table for the odd parity checker. Now let's find the K-map for the parity bit check. That means for A, B, C, P, combination for AB is 0 0 0 1 1 1 1 0. For CP is 0 0 0 1 1 1 1 0. This one is obtained by the combination 0 0 0 0. That means for this one. This one is combination is 0 0 1 1 0 0 1 1. This one is for the combination 0 1 0 1. That means 0 1 0 1. This one is for the combination 0 1 1 0 0 1 1 0. This one is for the combination 1 0 0 1 1 0 0 1. This one is for the combination 1 0 1 0 1 0 1 0. This one is for the combination 1 1 0 0 1 1 0 0. And the last one is for the combination 1 1 1 1. Okay, we get this type of K-map. In this K-map, again there is no octet, no chord and no pairs. All the 8 ones are in the single format. Okay, now try to simplify this K-map. We get here the equation like this. For this one we get the equation A bar B bar C bar P bar. For this one we get the equation A bar B bar CP, as so on. Then try to find the common terms, and after finding common terms try to simplify it. After simplification of this equation we get the final equation as Cp is equal to A XNOR with B XNOR with C XNOR with P. This is the final equation, and we can draw the logic diagram for the same. That means A XNOR with B can be represented by this. C XNOR with P can be represented like this, and we need another XNOR gate for the total diagram. This is the diagram for this equation. I hope you all understand this diagram and the concept of parity checker. Thank you.